This video focuses on graphing the inverse sine function. We have spent some time earlier this chapter focusing on graphing the parent function y equals the sine of x. So if you could go ahead and take a moment on your own, graph y equals the sine of x. Pi over 2, pi, 3 pi over 2, 2 pi. I'm going to go back into the negative direction, negative angles, negative pi over 2, negative pi, negative 3 pi over 2. Remember, you start at 0, 0, pi over pi over 2 up 1, over pi up 0, over 3 pi over 2 down 1, over 2 pi up 0. So there's one revolution. Now I'm going to go in the negative direction. Continue that pattern. And this graph, so far, without any domain restrictions, looks like that. A couple revolutions. If I were to ask you, given no domain restrictions, would this sine function pass the horizontal line test, then becoming 1-to-1? Would you say yes or no? No, it does not pass the horizontal line test. There's an issue there. It touches more than one time. And you'll see that if I kind of just do this in yellow. If I imagine here's a horizontal line, oh, there it touches 2 times, touches 2 more times. So it fails the horizontal line test. So for short, we call this the HLT. So it's not 1-to-1. So as it exists right now, when I graph this purple graph, it would not have an inverse like the first problem that we did earlier. But what we can do instead is we can cut the domain down to taking one piece that is 1-to-1. So I'm going to choose a different color here. I'm going to choose green. And I'm going to take this segment here, starting at the ordered pair negative pi over 2 down 1, to this piece here, pi over 2 up 1. So go ahead and highlight on your paper that region right there. Here's a bigger version of that. When I look at that green region that I've now highlighted, does that green region pass the horizontal line test? Yes, it does. So this region in the green passes the HLT, so it could have an inverse. So that domain that we just cut out is from negative pi over 2 to pi over 2. And the range is still the same. We didn't change the range at all. The range is negative 1 to 1. So in a little bit, we're going to construct the inverse function for this piece of the sine function. So I'm going to go back and review with you some of the ordered pairs that are on the unit circle that are taken from the special right triangles. And I'm only going to focus on the angles on the unit circle that are between negative pi over 2 and pi over 2. So here are my 4 quadrants. So in order for us to graph the sine function, y equals the sine of inverse of x, we're going to focus on quadrant 1 and 2, or quadrant 1 and 4. So here's quadrant 1, and here's quadrant 4. So let's review a little bit sine functions with the unit circle. So if I think of the 4 quadrants, and I talk about angle measurement of 0 degrees or 0 radians. So here's 0 degrees. It has the ordered pair on the unit circle over 1 up 0. If I asked you for the sine of 0 degrees or 0 radians, you need to remember that the y value is your sine value. Okay? So if I say the sine of 0 degrees, you should recognize at this point now that that's 0. All right? Now I'm going to go up to pi over 2. Pi over 2 is within the appropriate domain that we restricted. It has the ordered pair over 0 up 1. If I asked you for the sine of pi over 2, remember the y value is the sine, so that would be a value of 1. Now let's find some more ordered pairs. Now I'm going to split that first quadrant in half. Pi over 4, or 45 degrees. That ordered pair is square root of 2 over 2, comma square root of 2 over 2. The sine of pi over 4 is square root of 2 over 2. Let's do 2 more. You should start to recognize these as your reference angles constructed from the special right triangles. Here's pi over 6, or 30 degrees. Here's pi over 3, or 60 degrees. So we have the ordered pair, 1/2, comma square root of 3 over 2, and square root of 3 over 2, 1/2. Now, our domain, the piece that we looked at on the previous slide here, is from negative pi over 2 to pi over 2. So I've constructed the angles, the special angles in the first quadrant. I have to go down to quadrant 4, but it's asking us for negative angles. Let's go back and find those angles here. So we did halfway, but now this is not a positive angle. We want a negative angle. So that's negative pi over 4. That ordered pair you probably recognize now is the square root of 2 over 2. And then it has a negative square root of 2 over 2. So the sine of negative pi over 4 is negative square root of 2 over 2. 2 more. Negative pi over 6. Negative pi over 3. This is square root of 3 over 2. Negative 1/2. This is 1/2, negative square root of 3 over 2. Last one in our domain, negative pi over 2, ordered pair over 0, down 1. What we're going to do is we're going to take the angles around these 2 quadrants, quadrant 1 and 4, graph the sine function, and then we're going to inverse them, interchange them to find the sine inverse function graphed out. So again, these are the points I'm coming from. This probably looks familiar to you. We're going to be focusing on these angles here. All right. So what I've done is I've created a t-chart. The left-hand side is going to be the t-chart for the sine function. So we're going to start to list off some ordered pairs. So remember the sine of 0 degrees, if you look at your unit circle, that's in your notes, the sine of 0 degrees is, remember the ordered pair, over 1 up 0? Then let's try pi over 6. What is the sine of pi over 6? And what we're referring to is right here. This is your sine, this is your sine, this is your sine. So we're going to take those values. The sine of pi over 6 is 1/2. The sine of pi over 4 is square root of 3, or square root of 2 over 2. The sine of pi over 3 is square root of 3 over 2. again, the sine of pi over 6 is what? 1/2. The sine of pi over 4. Sine of pi over 3. Square root of 3 over 2. I'll go all the way up to pi over 2 because that's our last high value in the positive direction for our domain. The restriction, that little piece. The sine of pi over 2 is 1. All right. Now, going back, we're going to do the same thing down here. The sine of negative pi over 6 is negative pi over 2. The sine of negative pi over 4, negative square root of 2 over 2. Negative square root of 3 over 2, negative 1/2. And then what we're going to do is we're going to graph those. All right, so we'll continue on. So negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. The sine of negative pi over 6 is negative square root of 3 over 2. The sine of negative pi over 4, negative square root of 2 over 2. The sine of negative pi over 3, negative 1/2. The sine of negative pi over 2, negative 1, right? What we've done is we've created a t-chart of a group of ordered pairs that we could then go out and graph. So I'm going to have this be pi over 6, pi over 3. Well, these aren't really equally apart, but that's fine. Pi over 4, pi over 3, pi over 2. Again, they're not equal. Then same thing over here. Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. The highest we're going to go up is to 1, so I'm just going to have this be 1/2 here and then 1. Negative 1/2, negative 1. All right, let's graph them and see what we get. So 0, 0. Over pi over 6, up 1/2. Over pi over 4, up square root of 2 over 2. So about there. Over square root of 3, up square root of 3 over 2. And then the same thing here. Negative pi over 6. That should look familiar to you. That's the region that we just looked at. I'll come back to this. Right here in the green. We just regraphed that green section with lots of ordered pairs. Okay. We're almost there. We want to find out how to graph the sine inverse function. So earlier we talked about how do you find an inverse function is you interchange all these fun ordered pairs in the blue. So I'm going to change my color to purple. All of these ordered pairs in this chart to create our new sine function, inverse function, we're going to interchange them. So the first ordered pair stays as it is, 0, 0. The next one, over 1/2 pi over 6. The next one, square root of 2 over 2, pi over 4. Square root of 3 over 2, pi over 3. 1, pi over 2. Negative square root of 3 over 2, negative pi over 6, and so on. We're going to graph it in just a moment. going to go ahead and pause there, and then I'm going to start a new video.